What's going on? This is SDG Physics. My name is Tosh Dalday, and I like Batman. Corey the Thunder Law, a Harlem Globetrotter, breaks the record for the longest basketball shot. And let's assume that he throws it at 45 degrees, and I think that in the video we gave you the distance at which he threw it at. So the first part I ask you to find the velocity at which he had to throw it at in order to make the basket. And I told you, assume that that is at the same exact height that the, I said assume that the velocity is the same, or the basket is the same height as the basketball player. Well, that's actually exactly the same problem I just solved for you. So I'm going to just quote the answer. Velocity is equal to the square root of rg over sine 2 theta. That's it. Just plug your numbers in there and have at it. If, however, we assume that the velocity or the height of the basket is at a different height than the basketball player, which I think is a fair assumption. I'm not exactly sure how many basketball players are the same height as the basket itself. It's pretty tall. So then there's going to be a delta y in this case. And what we need to throw out is we can no longer use the range equation. Because the range equation, the danger about the range equation, this is why I told you not to memorize the range equation. It's because the danger about the range equation is it doesn't tell you, or it only works for landing and starting at the same exact height. But once you land at a different height, the thing falls apart. So we kind of got to resolve the problem from scratch. So let's just do how long does it take to get there. If he throws with a velocity v naught at an angle theta, how long? How long? All right, delta x equals, well, delta x is actually my range. So range is equal to v naught t, so that'd be v naught cosine theta times time plus 1/2 at squared. Oh, okay, well, plus 1/2 at squared, and 1/2 at squared is 0, because there's no acceleration in the x direction. I'm talking about the x direction specifically. So the time is equal to r over v naught cosine theta. And then, how, I guess the question is, how, let's apply the y direction now. So I know that this difference in height is the delta y is equal to, my delta y is equal to v naught t, so that would be v naught sine theta times my time minus 1/2 gt squared. All right. Sorry, that's a theta. Oh yeah, sorry. That's a theta, and there's a time times it. It's v naught sine theta t minus 1/2 gt squared. And my time is right there, so I just plug and chug this stuff into there. Delta y is equal to v naught sine theta r over v naught cosine theta minus 1/2 g r squared over v naught squared cosine squared theta. All right, this cancels out with that, and that cancels out with that. If it's right with you, I'm going to throw a cosine squared theta up. Essentially, I want to solve for v naught squared, so I just want to try to get rid of this 2. Put 2 here, 2 here. I'm going to get rid of that cosine squared theta. Put a cosine squared theta over here, and I'm just going to put a cosine theta over here, because one of those will cancel. That gets rid of that. All right. And then what I'm going to do is I'm going to move. Let's see. I'll just stick with that. So cosine squared theta delta y is equal to 2 sine theta cosine theta r minus g r squared over v naught squared. I totally don't know if that's the right way to go about it, but whatever. I'm going to take this over to that side, and I'll have negative, or we'll do it this way. G r squared over v naught squared equals 2 sine theta cosine theta r minus cosine squared theta. Alright, now what I'm going to do is I'm going to divide by this side, multiply by that side, and take the square root. So I have v naught is equal to the square root of g r squared over 2 sine theta cosine theta r minus cosine theta squared. I'm missing a delta y. Is that what I got? Yeah, sure. Now at 45 degrees, this ends up being 1 and this ends up being 1. Or no. Root 2 over 2, root 2 over 2. This ends up being 1/2, this ends up being 1/2. So at 45 degrees, at theta equals 45, you end up getting the square root of g r squared, and that would be 1 minus, or no, r minus delta y over 2, right? Okay, wait. Oh, there's a 2 over here. So that's true, yeah. So your velocity is equal to that. Now, what I think is interesting, let's take a look at this real quick. There's a domain problem here. And you won't see this if you plug in numbers at the beginning, but if you do everything in variables, this is where you'll get these really nuggets of awesomeness. The r minus delta y, that one, delta y can't be bigger than r, because I will give you a negative number. The negative number will give you a square root of a negative number. That's a problem. Also, r can't equal delta y. If delta y gets close to r, then this number will actually get really small, and that will explode this number in general. Which, if you think about it, if you're shooting at a basket that's really high, you need to throw that ball with a really, really high velocity. All right, another thing too is, if it's equal to each other, you won't be able to make it. So it's saying that if you are, 10 feet away, if you're 100 feet away from the basket is 100 feet tall, then if you throw it at 45 degrees, that would be r equals r, 100 and 100. It will never make it to the basket, no matter how fast you can throw it. You can throw it at super fast speeds. You could, if you shot a laser, then maybe it might work. But if you actually threw a ball super fast, then it will actually never hit the basket. So your velocity will go to infinity, and then it will just explode, because you can't have 0 in the denominator. All right, that's it. There's your final exam. Shoots, bro. Up out.